Okay, good morning, everybody. How are you? Good, 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 very good. So for those who know me, Veronika, McKillop, I chair the UK IPv6 Council, and I also work in Cisco as an engineer. And this time I'm not here to tell you anything about how UK is doing with regards to IPv6 rollout, even though we are doing great, guys. But I'm here today with my highly esteemed friend Tom, who I met actually 5 UKNOFs ago in London. And it was a very funny story because that was just a few months after the council started, and we were really trying to change kind of the perception of UK and how we were doing with regards to IPv6. You know, we've had some announcements from Sky and BT, and we were saying, okay, yeah, things will change, just hold on. And then Tom rocked up on the stage in London.
Oh, this is where I take over the story, I see. Having not been to the UK for a few months and just assuming that everything was status quo with IPv6, I made a kind of offhand joke about, well, you know, I'll come back in another 12 to 18 months and hopefully there'll be some additional progress. I was probably a little too flip in my pronouncement because afterwards, Veronika was very avidly disputing the point that we hadn't made progress with IPv6 in the UK, and just to be basically blunt about it, I've never seen someone so angry in my life, not in the context of technology. So we realized very quickly that we were on the same page in terms of advocating IPv6 adoption everywhere, and had I done just the requisite minimal amount of Googling on IPv6 in the UK, I would have seen the council meeting, I would have seen the exciting Sky announcement about them deploying IPv6, and I would not have walked into the trap that had been laid for me in such an unsuspecting way. But I'm really glad that we're able to get together and do a co-presentation on IPv6 address planning today. And, yeah.
Excellent. Thanks, Tom. Yeah. So basically, we got together because also we realized that we both have done some work with our customers with regards to IPv6 address planning, and we thought, like, Tom, he wrote a book, I've done Cisco Live presentation, you know, why not get together? Because that actually is one of the first questions when we talk with various people when they start thinking about their IPv6 deployments, like, if we get a prefix, how are we going to do the addressing plan? Because in many situations, people haven't done addressing plans for many, many years. So hopefully you will find this presentation useful, even though we say it's very brief, so it's really just top 5 things.
Excellent. So our agenda is obtaining an IPv6 prefix and some of the details around what's required to do that. And then, of course, once you have the prefix, slicing it up, slicing and dicing your IPv6 prefix. And this is where the trouble starts for most organizations, as Veronika just mentioned. They haven't really touched an address plan in a long time, and they certainly haven't touched an address plan where the addressing resources are as abundant as they are in IPv6. So with IPv4, where we're used to slicing and dicing and using VLSM, to absolutely use the minimum number of host addresses, we end up with IPv6 having an astronomical amount of space, and how do we carve that up? So then, of course, knowing what the standard sort of subnet sizes are, to the extent that we have one-size-fits-all subnets in IPv6, sort of knowing where those boundaries are and using them to your advantage in your addressing plan is critically important. And then the Nibble boundary rules that sort of go along with that to help you know where to actually divide up the space. And then finally, Veronika's going to talk a little bit also about the service provider CPE requirements for addressing and the types of subnet sizes that we're likely to see there. And then we'll look at a couple of brief examples of actual address plans to sort of see what both service providers and enterprises do when putting together their address plans.
Excellent. So let's just get started. How does an organization obtain an IPv6 prefix? So I'm talking about ISPs, because you guys who are in the room, just hands up, because I can see how many ISPs we've got here. That's about 50%, maybe even more, which is great. So you know you've got the task of not only obtaining the IPv6 prefix for yourself, but also for your customers. So you really need to think about the size of allocation, what you can get, and how you're going to split it up for your customers, what you're going to give out. The question usually is, how large IPv6 prefix should we get? So in the past, few years ago, in the RIPE region, it was usual to get /32, pretty easy. Nobody was questioning anything. But for some very large ISPs, and we will give you examples in few slides. Basically, they would go and request a lot bigger v6 addressing space, but the standard one kind was /32. The rules have changed a few years ago, and now the standard allocation to an ISP is /29. In RIPE, you really don't have any problem getting v6 prefix. It's actually processed pretty quickly. And then the second question is, what size of prefixes should we suballocate to our customers? So for enterprises, and Tom will talk about it in more details, the typical site allocation is /48. If we are looking at broadband CPEs, then current trend is /56. There are some new trends coming on board, and we will talk about that later towards the end of the presentation. Just bear that in mind that current best practice for enterprise customers is /48. Obviously, you can give them a larger prefix if there is a good reason for that. Or for the broadband CPEs, it's /56.
Yeah, so for enterprises, the challenge with enterprises initially in terms of getting IPv6 address spaces, they usually don't have a lot of experience dealing directly with rears, and so the decision that they have to make pretty much immediately, which they usually don't have enough good information and enough good IPv6 sort of established practice to know that they're sort of walking into a challenge for themselves in terms of not getting either the right kind of allocation or not getting a large enough allocation. So if you've just done the minimal amount of research and you're looking at having a /48 for your entire organization, and you start to do the math and you break it down and think, well, I've got, let's see, 65,000 /64s, and each of those /64s has 1.8 times 10 to the 19th host addresses, well, I'm in pretty good shape. I can take a /48 and I'll have enough IP resources for indefinitely. But of course, that's actually not how we end up routing IPv6 on the internet. In the case where an enterprise has more than one site, and it's possible that they may have more than one head end, or they're multi-homed, then a /48 is not sufficiently large. And so right away, they're in a scenario where they should really be getting more than a /48, and they should probably be getting provider-independent space directly from the regional internet registry so that space is portable and so that they won't have to look at renumbering at some point down the road. Being numbered into one allocation, provider aggregatable allocation from one service provider means they're kind of locked in unless they want to plan on doing renumbering, which of course nobody likes to do. So then the additional challenge as well is that actually gauging how much IPv6 address space is going to be sufficient for the enterprise without also knowing about the fact that most allocations happen along Nibble boundaries. So, thinking, well, if I have two sites, then maybe I'll just go ahead and get a /49, and a /47, and I'll have two /48s and be good to go. But of course, most of the rears and most of the folks that are doing the IPv6 allocation are reserving Nibble boundaries worth of additional space to allocate to the end users and to allocate to the organizations. So if you look on this chart at the bottom here, you kind of see what smaller enterprises, if you have fewer than 16 sites, but more than one, your chances are you're going to get a /44 for 16 /48s, and then it just sort of goes up from there. And we'll see later in the presentation some of the largest allocations that have been given out to enterprises, say, in the North American region. Oh yeah, so and then the next challenge then, and this is really, I don't know how much this affects enterprises typically, smaller enterprises not so much, but larger enterprises that are doing business in multiple regions, then if they're only used to dealing with IPv4, chances are when they're looking at, say, their routing policy globally, they're thinking about, out-of-region announcements really not being something that they can feasibly do, and of course that creates potential challenges with asymmetrical routing. With IPv6, right now, the sort of standard is that out-of-region announcements are to be accepted. So, if I get a block from RIPE, or if I get a block from Aaron, and say I'm doing business in Asia Pacific, there is some expectation that I'll be able to announce that Aaron space or that RIPE space in the Asian region. Whether or not this continues to be true as we go forward, it's sort of, we don't really know. Nobody has a crystal ball. Right now, it seems that will be something that will be allowed. Out-of-region announcements will continue to be allowed in the IPv6 address space, and so we hope that continues to be the case, because obviously that gives you some flexibility in terms of determining what your routing policy is going to be, and the best use of your numbering resources without being locked into announcing in only one region. And right now, of course, as we've mentioned a couple times, the /48 is the smallest routable prefix, and that I don't know that that's going to change anytime soon. Hopefully, the balance between keeping the DFZ manageable and giving us some routing flexibility is the challenge there.
Yes, and so just to reiterate the point of requesting large enough allocation, here are a couple of examples from the RIPE and ARIN region of the largest allocation that are currently have been done so far. So you can see /19, pretty easy to do and to get. It's Deutsche Telekom, France Telecom, and quite surprisingly for some is the UK Ministry of Defence. So we've got a good stash here in the UK as well. And then it's /20, Telecom Italia and TeliaSonera. In the ARIN regions?
Yeah, so in the ARIN region, the Comcast is one of the very early adopters and promoters of IPv6, obviously in the US. And I think they have the largest, from my checking, they have the largest allocation with a /20, which of course is 4,096 /32s. It's a fair amount of space. Of course, they've got some hierarchy in their network to deal with. On the enterprise side, we have the Veterans Administration, which if you're not sort of familiar with the U.S. government, the way that they handle the veterans services, they basically have regional offices. There could be a Veterans Administration office pretty much in any medium-sized town in the U.S., and so they have a tremendous amount of sort of geographical hierarchy that they have to contend with. And they actually started out with, I think, a /29 worth of IPv6 address space, and when they started doing their planning and seeing how much sort of inter-region hierarchy that they had, they went back to ARIN and requested a much larger block, and so they ended up with the /24. So for an enterprise, that's a substantial amount of space, obviously 256 /32s. But they're using all of it in terms of carving up the space to do more hierarchy based on their particular deployment, their network.
So really the point we want to make here is that don't worry and don't be afraid to request large allocation, because there's at the moment still plenty of IPv6 and you can get that. So now we're going to look at the subnetting of IPv6 allocation assignments, and that's Tom.
Yeah, so as we mentioned already, making sure that you get a large enough allocation at the outset is critically important. So determining whether or not an allocation is large enough requires that you have a little bit of IPv6 address planning knowledge, and basically it boils down to being aware of the fact that since we're dealing with Nibble boundaries, where we want to start carving up our allocation and allocating blocks of subnets along Nibble boundaries as opposed to peeling off individual bits. And there's reasons for this that we'll look at a little later in the presentation. But what ends up happening with a lot of organizations is they fall immediately into a sort of IPv4 mindset where they're used to looking at their network and starting off with an initial block of space and thinking, well, I'll just subnet, I'll continue to subnet to the right and carve out smaller and smaller prefix blocks in order to take advantage of the space that I have available. And that's actually the backwards practice with where we're at with IPv6 address planning in general, knowing that I can always go back to the rear to get a larger allocation to support what my network actually has in terms of levels of hierarchy, in terms of the overall size of the network, et cetera. So the idea then is you start off with a slash, whatever the size of the network is, you start off with that allocation, and then you think of the groups of prefixes that you have that fall into these Nibble boundary buckets, which are basically 16, 256, 4096, and 65K, and go up from there. Which is not very super granular, right? Because generally, I might have 20 of something. I might have 20 sites, for instance. And then if I'm immediately jumping up to a /40 that gives me 256 sites, clearly I'm going to have a lot of space left over that I'm not using. And it's IPv4 thinking that then kicks in that says, well, I'm wasting space. But of course, that's not what we want to think in IPv6. I have that space held in reserve. It's not going to get used anytime soon, but it's going to keep my address plan tidy by just using that next Nibble boundary and making sure that then I can map everything into my existing address plan.
Now, when you've decided, how you're going to subnet your IPv6 prefix, there are a couple of areas that you need to really look at carefully. So, as we said, in enterprise, what you're going to get per site is at least /48. But then that's kind of clear. Now, when we look at point-to-point links and loopbacks, again, people are asking questions. And then for the point-to-point links, you need to decide whether you're going to allocate /64. You can actually put it in your addressing plan, but then there is a difference between allocation and what you configure. Typical practice in order to avoid neighbor discovery cache exhaustion attacks is to configure /127. The length of the prefix on the link has evolved over the years from /126 now to /127. So just basically keep that in mind, what you're going to allocate in your address plan and what you are going to configure. On the LAN segments where you've got hosts, typical for a VLAN or is /64. On the loopbacks, as in IPv4 world, we've got /32. In v6, we are configuring /128. And there in the addressing plan, you have, again, two different options, and it's up to you what you're going to choose. Both of them give you certain operational ease when you configure them. So you can say in your addressing plan, I'm going to take 1/64 in a site, and I'm going to basically configure different interface IDs for all the loopbacks in the network, but the operator is you're going to look at the v6 address and you know that this is the prefix, this is /64, that is assigned to loopbacks. Or you do it the other way, you take multiple /64s and you configure always the same interface ID for a loopback. So again, looking at that portion of v6 address, you know that you are looking at a loopback address. What you need to keep in mind, in your routing table, you will be announcing /128. So check with your vendors, what number of longest prefix match records your devices in network can actually carry, because that is usually smaller than the number of /64s. Now onto the Nibble boundary.
The exciting Nibble boundary in IPv6. So one hex character then for a nibble, for every nibble that's significant in the prefix, and this really helps you keep your address plan tidy. It makes it easy to recognize what portion of the prefix is the network side and what's left over for the subnets that are allocated out of a larger prefix. And so then, of course, this allows you to get very efficient with your hierarchy within your network, which allows summarization and network ACL writing to be a little bit easier. We don't have some of the crazy things that we would do in IPv4, where we have the subnet mask and we do things like least significant bit masking. But we're in a different space where we have basically a parent prefix with everything within that parent prefix belonging to one level in the hierarchy for the network topology for summarization, or perhaps a security zone. And as long as we stick to the Nibble boundary, then we've actually got the ability to identify what that block of subnets is very, very efficiently. And so again, we're dealing with the very ungranular buckets of 16, 256, 4096, and 65,000. And so when you're doing the address plan, the sooner you get comfortable with sort of deciding how much of one thing that you have and what area and which of these sort of buckets it fits into, the more progress you'll make in the address plan. So the legibility of prefixes, two more clicks. Yeah, there we go. So the legibility of prefixes then, so as long as you stick to the Nibble boundary, if you look at that first prefix there, it's completely unambiguous in terms of having that network prefix represent all of the blocks within, all of the subnets within that parent prefix. As soon as I move away from the Nibble boundary, as soon as I start to peel off individual bits, then the significance of the network prefix can't be determined without looking at the expansion of the next character in the address. And so then as a result, I have to look at the next character in the address to know whether I'm looking at the first half or the second half, or potentially the first quarter or second quarter or eighth, et cetera, depending on the size of the prefix. So there's a tremendous value in making sure that you stick to the Nibble boundary and keeping the address plan tidy and readable, which of course in network operations goes a long way to figuring out where the problem is sooner than later. So then mapping locations and functions into the IPv6 address prefix using these nibbles then is something that we can do much more effectively in IPv6. We try to do this in IPv4. Even if you have the 10/8 space, you run out of bits pretty quickly. You only have like 254 things to play around with. In IPv6, we've got these larger ranges that we can assign then to location or function, depending on whether whether we want summarization as sort of the principal way in which we're sort of slicing and dicing the network, or whether we want security policy. This is just one example. You can take a /48 and you can assign the first 16 /52s to location. So you could have, you just hold the 0 subnet in reserve, start numbering from 1 as you would normally do. And each of your buildings then would have a dedicated prefix, dedicated /52, and within each of those /52s, you could potentially have 4,096 /64s, and each of those each of those nibbles within that /64, each of the characters then would be significant for whatever you assigned it to, say a VLAN, or in this case, that's the example. It's easy to overdo this approach and to get to a point where you've sort of defined function or location that totally takes away your flexibility to scale the network in the future. I ran into an instance where somebody running a data center was actually assigning server operating system types into nibbles within the address prefix, and maybe that will work for them, and maybe, depending on their deployment, maybe that makes sense. It wouldn't be something that I would do personally, but it's easy to overdo it, so be careful in that regard.
Excellent. So the final point we want to make here is about CP addressing for ISPs. And basically where it all started many years ago, it was site allocation. And it didn't matter whether it was your data center or a business CP or a broadband CP. Basically, the recommendation was /48. And I think at some point people started to think, well, this might be a little bit wasteful in the broadband network, so what are we going to do? The current standard, as I mentioned at the beginning, is /56. If you think about it, you can do /56 in your addressing plan, and you can actually assign a smaller or longer prefix to a CP. So, for example, you reserve /56 per broadband customer, but you actually assign /60 to the CP. That still gives them to the power of 4, that's 16 subnets in the home. And again, if you, in the future, roll out some services and you want to distinguish that on per prefix basis, you are carving it up from the /56. However, now we've got HomeNet in the IETF, and these guys are working really hard looking at how to actually deal with unmanaged home networks and basically having different devices or having also multiple connections into the house. I've got more details about it on the next slide. That's for your reference. But the question is, what will be, again, the CP standard prefix assignment? HomeNet is looking at /48. And then there is another case in service providers world, and that's SP Wi-Fi. And what do you think about giving /64 per host in the deployment? So just for your reference, the links are working in the presentation in the PDF that you are going to get. We actually had a couple of presentations here at UKNOF, some already like 2.5 years ago. One was very recent in January 2016. And first one was the HomeNet presentation by Mark Townsley. Second was Gunther van der Velde, who was talking about the IETF draft for unique IPv6 prefix per host. If you think about the scale of and the number of /64 you need in SP Wi-Fi deployment, then you might again rethink the size of V6 allocation that you're going to request from your RIR. And now, just quickly, some examples of the addressing plan.
Yeah, I want to leave a little bit of time for questions. So to summarize this slide, this is taken from an actual enterprise in the US, financial institution, and I just thought it was interesting that you could summarize an entire enterprise addressing plan with a few bullet points, and that's sort of the power of sticking to the Nibble boundary and making sure that your plan is sort of carved up using IPv6 address planning principles. To be able to look at something like this and sort of get the high-level view of what the address plan looks like is something that's possible in IPv6, or should be. So if you have more than a few bullet points for an enterprise to at least describe the high level of the address plan, then you're probably off in the weeds somehow.
Okay, and just a graphical example of a SP addressing plan. This is actual SP who is here in the RIPE region. And basically what they got from RIPE was /29, and then they split it up to 2 /30s. And they dedicated the whole /30 to their subscribers because that's their core business, right? And then the first /30, which is kind of for their own internal needs, they used some of it for private addressing, then another /32 for internal addressing, external, and then it kept one /32 as a reserve, which is always a good idea. We really didn't emphasize it in our talk, but always keep in mind that it's good to keep a reserve on every level of the hierarchy of addressing plan. And then further, they broke down the /32s into multiple /40s. They kind of held onto the rule of the Nibble boundary, and that helps them to keep the addressing plan pretty neat and tidy, yet they've got plenty of space for growing their network and working with more IPv6 prefixes. So just to summarize.
Yeah, so just quickly, obtaining an IPv6 prefix, making sure you get a large enough one, making sure that you pick the right kind, subnetting using the standard subnetting sizes in most cases, working with the Nibble boundary, making sure that you're sticking to 4-bit prefixes in multiples of 4. The ISP approach to CPEs, which we saw, and then the example of the address plan. And finally, I just wanted to say, we saw recently that Sky Broadband was at 90% IPv6 adoption. I think the UK IPv6 Council and Veronika share in some of the success related to that, and I just wanted to congratulate her for that today. And also, any of my proceeds from my IPv6 address planning book this month, a vast sum totaling likely tens of pounds, I'm going to donate to Veronika's favorite charity.
Excellent. Thank you very much, Tom. So here is for your reference some resources. Tom's book about V6 address planning, also a link to my presentation. The video recording is available online on the Cisco Live portal. And also I would like to emphasize that RIPE is doing a brilliant job in this region for the community, that they've got lots of resources on their website, and they regularly organize webinars where people actually can work on an addressing plan, can learn how to do that. So I would highly recommend for you to leverage these resources.
Okay, thank you both. Questions? I see one from Ray at the back there.
Yeah, hi, Ray Bellis, ISC, with my co-chair of the HomeNet IETF working group hat on. We actually have no working group documents talking about /48s at the moment. Still /56 is the recommended allocation per RFC 7368, whose editor is just walked in front of you. So it's still /56. But we do have something else that may be of use, maybe not quite ready just yet, which is the source-specific routing. And with that, where essentially each host can figure out, if you've got a multi-homed connection, which route to take through the network. It's already in the Linux kernel. We've got routing protocols now being developed to take care of that. Hoping that might actually get rid of some of the need to use PI space if you want to have the resiliency of multi-homing, but without needing to have your own PIs injected into the global routing table.
Okay, yeah. Just that comment on /48, I think that was made at the UKNOF in January, because that topic came up and somebody mentioned their /48, so that's where the information is coming from.
Yeah, it's not under consideration actively in the working group.
Okay, thank you for the clarification.
Okay.
Rob Speed, BBC. It's just my usual rant about how we're breaking up IPv6. If we're giving /64s to a host, there are probably more addresses available to it than there are atoms in that device. It just seems a bit of a waste. I get this.
I think that's
yes and no. So yeses, no's.
There's
is that from a routing
majority
perspective,
of hands
or is it
saying no?
Because if you don't do that, Slack doesn't work.
The comment is that if we don't stick to /64, Slack will not work. I'm doing it for the webcast.
Okay, talk to me afterwards. I've got some calculations based on the consumption of /48s with the existing allocation in V6, the 2000/3 global unicast allocation, the rate at which that's being consumed, how much IPv6 address space we'll have with still 82% left over that hasn't even been allocated yet. So
20 years' time?
20, 50, 100 years' time. IP will not be the protocol that we're using by the time we even come close to running out of the existing global unicast allocation.
Excellent, but thank you. IPv6 is always a heated discussion. Appreciate your attention. Have a great day.
Thank you.